Hi, good morning, everyone, ladies and gentlemen. Lovely weather in Bangalore, Chennai, where Mr. Gopkumar is addressing. I think they're hit by a cyclone called Mandosa or something. I really don't know. It's something to start with, but lovely weather in entire southern part of India. And what a wonderful day today. And the subject, electrical safety audit. It was a need of the hour. We all aware how the electrical safety audits being conducted in most of the buildings. So whenever there's a fire in a building, whether it is a commercial or a healthcare or a hospitality industry, immediately the need for the electrical audit arises. Do we have any standard for electrical safety audit? How periodically we need to do this? Is it every year, every once in a 6 months? And how do we need to really do a safety? And who are those people who can do audit? So today, Mr. Gopakumar will be touching upon this. Whether are we doing rightly? Are we capable of doing the right way? The safety audit is what is going to. The subject is quite huge. The subject is quite huge. So we divided into two parts. And as I was chatting with many of our participants who are quite regular, so they were suggesting that make it more interactive, get us also, talk on this. So we'll try to, adopt this to make it more interactive session. I'm sure today we'll try. And those who wish to interact with Mr. Gopakumar, specific to this, my request to all the participants is stick to the subjects that we are covering. Let's not go to the earthquake. Let's not talk about the short circuits and all that. So it makes sense for us to address to this subject. So if you're talking to us, you're coming online, please stick to the subject that we are addressing today, that is electrical safety audit. Myself, my name is Dominic. I've been in the fire industry almost now, 35 years. Through Gopakumar, I'm also learning about electrical safety. So, as I always believe, knowledge and learning has no age. So while I'm, hosting this, I'm also learning. It's amazing to see the knowledge that is there in the library to share. So I've been, the founder of the Fire and Security Association of India. Now it's become one of the premier institutions. Then also we have a focus forum of critical utility services, which brings all the professionals in the construction industry together on a single platform. I want to thank Fire Safe India Foundation. I want to thank CAVO, all the supporting organization for our webinar series. As you are aware, we started almost 1.5 years back through the support of Cape Electric to begin this knowledge series. As they are almost 25 years in this business, they found that knowledge is the need of the hour. The way we do installation, the way we practice, Mr. Cooper decided that let's carry out our own webinar series that can change and make our nation more safer. I don't need much introduction about CAPE, a well-known company today. And in 2022, this year, they launched Solve, a digital platform as a knowledge and process partner to ensure safe operation of low voltage electricity. And Mr. Gopakumar is a very active member in various standards and codes, IEC, National Building Code, and is a working committee member and in the NEC. So there are a lot many contribution he's been doing in the standards and codes. He carried out more than hundreds of case studies, failure analysis of electronic equipment, and hundreds and electrical accident analysis. So over 1,000 training, he's been traveling length and breadth. Today, he is more demanded in rest of the country like Philippines, South Africa. He's traveling now. He started traveling everywhere. People are appreciating his knowledge. And I'm sure that the year 2023, his presence, his knowledge will spread across the globe, not limited to our country alone. He's a member of working group of various IEC and BAS committee, which I mentioned below. And very interesting is he has published an article about fire safety in various magazines and published a book called Missing Link in the subject of electrical safety. Now, I think I must request Gopakumar to release the second edition of Missing Link. When you gather all those webinar we have been conducted, I'm sure he can write volume of books that is missing in our industry. So I would like to welcome Mr. Gopakumar to begin this first part of electrical safety audit. I request once again all the audience, the participant, do not post your question in the chat box. There is a Q&A box that is available in this Zoom. So put all your question answer. Please mention your name. Mention your name, that's important, and relevant to the subject that we are speaking. So we will not be taking any question not related to today's subject. With this, I welcome Mr. Gopakumar. Over to you, sir. Thank you.
Thank you. Thank you very much, Mr. Dominic. Yeah, thank you. Thank you very much, Mr. Dominic. Welcome all participants for attending this program. Today we are going to discuss about electrical safety audit. As Mr. Dominic told, what is the meaning of audit? We will see a little bit in detail today. Hope my sound is clear. Also,
yes.
Thank you. To start with, last few programs, this is, I think, our in last 1.5 years or since 2020 June. This was about 140th or 142nd program. Nowadays, I stopped counting. Also, along with blue and gray, this is, I think, about 30th program, which we are doing for the last.
And we have covered almost 8,000. Today, I was just calculating number of people who are participated, the database that we have, almost 8,000 to 9,000 people are attending this our programs. And today, Gopakumar, just for your information, we have 830 registration. Like last time we did on Sunday, that also crossed 800 participation. And today being Saturday, working day for some people, we still have 830 participants. It's very encouraging, very inspiring for us to do more and more. Thank you.
Yeah, thank you. And I think about 250 participants are already watching this program, plus on the YouTube and other social media. Now, anyway, let me go to the subject straight away, electrical safety audits. Before starting the program, a small introduction. You can see a new logo now. All of you are, those who are participating in our programs, you know very well that we were doing Vidyut Surakshit Bharat Abhiyan, which was a highly successful program. We could attend, or there were about 25,000 plus attendees in this program, which was conducted for almost 1.5 years. Now, we get a lot of requests to do something for electrical safety, and there was a noble idea given by engineers of electrical inspectorate. Also, one moment, I have to hide the panel, hide floating meeting. Yeah. Also, let me switch off my camera, because sometimes with the camera it's very difficult. Now, with the support of the engineers from Electrical Inspectorate, CPWD, PWD, Defense, Railways, and industries and private sector, there were a lot of demand or there were a lot of requests to start some kind of an association so that everybody can be involved in making a safer India. As a result, we were trying to register an association as a society. So that all these activities can be, the knowledge sharing or the skill development activity can be carried out further. So we registered the association, NFE, National Federation of Engineers for Electrical Safety. So we are setting up the website. We are setting the other goals, vision, mission, and goals of this particular the association. Probably within a week or within 15 days, we will come back with more news on the National Federation of Engineers for Electrical Safety. We have great plans, and also the trainings which were carried out under the name of Vidyut Surakshit Bharat Abhiyan will be now taken over by National Federation of Engineers. We have there are about 13 founding members, starting with Sri Apau, retired Chief Electrical Inspector, Tamil Nadu. Also, Mr. James Kuti Thomas, retired from Kerala, plus engineers from TPWD are there, engineers from railways are there. So with their support, we could register the association and we are starting the activities. Now, going to today's subject, challenges in electrical installation. All of us should understand that an electrical installation, once installed, changes are difficult and sometimes rarely changes are possible. If you install, if you put a conduit, pull the wire through the conduit, fix it inside your concrete, that's it. You cannot change it further. If you wanted to change, this becomes a major work. Similarly, in an industry, if you pull the wire through a chamber, then it's very difficult to change. So once installed, the changes are very difficult in an electrical installation. This means when you do the job for the first time, you have to be very careful and you have to do it perfect. In several applications, switching off for the purpose of making a test is impossible, or sometimes it's very difficult. Say, for example, in a hotel, if we wanted to make a periodic verification, or if we wanted to switch off the supply and make an RCD test, for example, sometimes we have to wait for a few days. They say the rooms are occupied, there is no room left out, and we have to wait and spend a lot of time for doing this verification. Similarly, in a hospital, switching off the power supply and making a testing or verification is almost equal to impossible, very, very difficult. So this also shows that while doing the job at the first time, you have to do a perfect job. Several parts of the wiring are hidden and inaccessible. All of you knows, if we look at our house or our office, you will be able to find out that most parts, say for example, you have a false ceiling, and above the false ceiling, we really don't know how the wires are routed. And if you wanted to check it, most of the time it's impossible, because it's already, you have a false ceiling and you have to damage it. Very difficult. The fourth part is the connected load and its technology are rapidly changing. You know very well that earlier we had air conditioners, now we had air conditioners with rectifiers inside. That means AC-DC conversion is happening, inverter air conditioner, inverter refrigerator. A lot of semiconductor-based devices are coming into the picture. Earlier it was the incandescent lamp, then tube light, then CFL, now LED lights. So each of these devices, the way it operates differs. Say, for example, modern devices are creating more and more harmonics. They are switching, and the multiples of the fundamental frequency are sometimes creating more issues into the line. Similarly, increase in load. Once when we start an electrical installation, we think that, okay, we are going to have X amount of load, but after some time, we need to increase the load. So this is also a challenge, but you please note that in developed countries, rather than increasing, the load is decreasing because of energy efficiency, because they already have a maximum number of electrical appliances connected to their electrical installation, and now they go for more and more energy efficient things. As a result, the load is actually developing, whereas in our country, the load is actually increasing. Change of consumer to prosumer. So far, we were utilizing or using electricity, we are consumers, and now we slowly change to prosumer. We are going to have new kind of electrical generating systems in our roof, sometimes solar PV, sometimes small wind, or a lot of new technologies are coming up. the system which were working in the earlier situation may not work in the new situation. Say, for example, you have a TT system earlier in your house which was working for example, for quite some time. Now, if you wanted to change or if you wanted to add solar PV into your network, sometimes the same network, solar PV, will be very difficult. It may work, but the question is whether it will work safely or not is the question. It may not work safely. Another challenge which we always face is the black box solution. What I mean by black box solution is first we should understand that electrical safety is not about a product which can be brought from the market. No, like I want 10 kgs of electrical safety, or I want 5 numbers of electrical safety. That kind of this is not a product which can be brought and installed in your system, and there is no one product available in the market which will make all your installation safe. If somebody says, I have a product which will make the entire installation safe, please note that this is almost equal to impossible. Whereas if we look at in the market, you will get a lot of black box solutions who claims that my black box is the ultimate solution for all the problems, all the daily problems which is faced in the electrical safety scenario. Sometimes one of these classic example is, say, for example, all of you know very well, all electrical engineers know very well, chemical earth. So chemical earth has been projected as a solution for all your problems. This is I would say, a black box solution. Nowadays, chemical earth people, the companies, those who are involved into chemical earth, they started changing the name. Somebody call it as alpha earth, somebody beta earth, somebody sigma earth. Everybody claimed that I am the world's best, or India's best, or Asia's best, and all these claims. Somebody says my earth compound grows capacitor inside. As a result, it gives a much better value. So black box solution, basically what I mean to say is black box is a solution which says basically a foolish idea and with exaggerated claims. Black box is referred to have unscientific product with exaggerated claims. So this is a big threat in the industry. Some of the examples we can also see, for example, digital grounding device, which is quite common in the industries, especially in telecommunication and instrumentation industry. Black box, the digital grounding. This is actually a highly dangerous equipment. This digital earthing system creates a TNC network in your building, which is actually illegal. Very, very, very dangerous. Now, the next point is normal persons work in locations where skilled or instructed people are required, or sometimes supervised by skilled or instructed people. These are actually missing. A person who doesn't know much about the subject is working or sometimes handling an electrical apparatus. This also creates a hazardous situation. Say, for example, opening up a panel board inside which contains some live parts, and without proper PPE, somebody putting a screwdriver into it and ending up with trouble. So these are also creating some of the issues. I have put only 8 points, but if we start putting the number of points, you can find out probably 100 reasons for where we violate electrical safety. So due to these reasons, which is told in the previous slide, any compromise in design, erection, and the initial verification, it can create a serious safety and reliability challenge. In the sense, after installation, you cannot change it, you cannot switch off, you cannot go and test, you cannot access the wiring. So don't compromise in the design, in the erection, and in the initial verification of your electrical installation, because if you have a perfect electrical installation, it will serve for at least 40 years or 30 plus years. Now, to enhance safety, what we do is safety audit. The word safety audit is very interesting to understand. Please note that audit is a checking, sample checking. Sample checking in the sense you have 100 circuits. You check three circuits on a sample basis and you make an audit. Or you check 10 circuits and you make a safety audit. This actually is illegal as per the standard. The standard IEC standards never use the word, or very, very rarely use the word safety audit. The word which is used in the standards are always verification. As an example, I will show you from some of these standards, just to show you how these standards are written. I am showing you the standard called as 61936 Part 1. This is also becoming an Indian standard. Power installation exceeding 1 kV AC and 1.5 kV DC, Part 1 AC. This standard is talking about the electrical installation above 1 kV. I am just searching. You can see on the right side in the find, I am just searching the word audit. You cannot see any word audit in this particular standard. Whereas if you look at the word verification, you can see verification is quite common. Verification, approximately 21 places in this particular standard, the word verification is used. I'm just showing you also the standard IS 732. All of you know very well. Nowadays, we talk more about IS 732, Code of Practice of Electrical Wiring. This is the Indian standard. And now here also, I am checking the word audit. There is no word called audit in this particular standard. Whereas if you look at the word verification, it is reflecting in almost 77 places. 77 places verification is written. Similarly, I am showing you the standard for lift, the ISO standard for lift. So audit is never there. Only audible word is there. Audit is not there. Whereas if you look at the verification, verification, verified verification, there are 24 places verified is used, 18 places verification is used. Next standard, lightning protection standard 62305 part 3. I'm sure all of you know about this standard as well. Here, let us search for audit. Of course, no audit, then the word verification. So verification is used 4 places in this particular standard. A maintenance program should contain provision for the following: verification of LPS conductors and system components, verification. So always the word which is used is verification. It is not the audit. So once when we read it, we have to be very careful in understanding this. I am also showing you the standard from about UPS. Let us search the word audit. No word called audit. Verification. Verification is used 13 times in this particular standard. So basically what I wanted to tell you is the word audit is actually not applicable for an electrical installation. Instead, what we have to do is verification. Audit is a sampling process. A chartered accountant makes an audit. He don't go through the entire accounts. He checks on sampling basis. So whatever we do on sampling basis can be called as audit, and whatever we do thoroughly. For example, fire safety. It's not fire safety audit. It is fire safety verification. So please refer to the necessary standard. You will be able to understand the meaning and the complications of this particular standard. The difference between audit and verification is, in a verification, you are supposed to test, inspect and test all the points. In an audit, not all the points according to your convenience. So the auditor can decide the amount of things which he is supposed to do, whereas in a verification, he doesn't have he cannot make a decision. He has to go as per the standard, because electrical or fire installation, we are talking about safety of people. Say, for example, in a safety audit, in an ISO 9001 audit, for example, if you find two non-compliances, you can rectify it later on. Whereas in a safety audit, if you find two non-compliances and if you try to rectify it after some time, within this time, there can be an accident. So safety verification is the correct word. So electrical equipment and the installation need verification during its design, erection, commissioning, and periodically. It's very much important. Not only during the product testing, verification is required during design of the electrical installation, erection of the installation, commissioning of the installation, and periodically you should do verification. The other word which we use, say for example, you have a motor. Before selling the motor, the manufacturer is making a type test. So that is a totally different thing. It has nothing to do with verification. There, the motor is tested to find out whether it is in compliance with the standards. So, with this background, let us start to use the word verification. What do we do actually in safety audit? In a lot of places, especially in high-rise buildings, especially in IT offices, electrical safety audits are carried out as per NFPA, which is an American standard. Sometimes the British standard BS 7671 is used. Most of the time, the auditors are not aware of the Indian standard. Please note that equivalent better Indian standards are available, and you should follow the Indian standard for verification. Mostly the auditors, I don't use the word verification here because conventionally we are only doing audit. We don't have the habit of making verification. Conventionally, the auditors are doing some kind of physical check. They run around the installation, they walk around the installation, find out whether any hanging cables, dust on the panel boards and so on are there. Then they check the availability of general condition, availability of PPEs, signboards, circuits, charts, tables, and so on. Plus, in some cases, the load flow analysis is also made, like the used power, the reactive power, and so on. But please note that load flow analysis is not a safety subject; it is something else. In almost all the electrical safety audits, testings are carried out. I have put 3 testings which is generally carried out in the case. Not all the 3 are generally carried out. The first one, earth pit resistance, the resistance measurement of the earth electrode is always carried out. The second one, IR, insulation resistance, which is not done very carefully, but sometime the IR measurements are done, insulation resistance, and thermography. In modern buildings, thermography is done because people believe that by making a thermography, you can achieve safety, which is absolutely not 100% correct. Also, I've put underline 2 things, the earth pit resistance measurement and thermography. Please note that the earth pit resistance measurement has been removed from the low voltage electrical safety standards a few decades back internationally, and even in the IS 732, if you look at the 10 testings, the earth pit resistance measurement is not mandatory. The technology is already changed, not now, 20 years back. Similarly, thermography is not a recognized test or recognized verification mechanism in the standard which I have shown you earlier. Those standards. Thermography, of course, for solar PV, yes, you can do that. But for an electrical installation inside a building, thermography is not recognized until now. So, what I wanted to tell you is, at the moment, under the name of electrical safety audit, we do something. The question is whether they are really helping the improvement or helping any improvements in the consumer premise. And most of the cases, more than 70% of the cases, please note that I have been getting questions from hundreds of customers. The safety audit reports are being shared with me. I am reading the safety audits and I'm responding back to the clients. And most of the safety audit reports which I see, more than 70% cases, Additional earth bits and chemical earths are recommended. And the sad part is it's always recommended as per IS 3043. As a member of ETD 20, I know very well that this chemical earth or this additional earth bit is not going to help you. So if anybody wanted to recommend chemical earth bit, you recommend. We have no issue. But the problem is, don't claim that it is as per IS 3043, because IS 3043 never written in this fashion. So in fact, this chemical earth or these additional earth bits, it's actually a violation of the standard. So by looking at the safety audit reports, what we feel is Indian standards are required or Indian standards are referred only to violate, whereas all the other standards as per NFPA, BS, all these things are mentioned in the standard. The client most of the time doesn't know what the NFPA says or the BS standard says. Actually, all these wordings, high wordings like NFPA, BS and all, these are like, big names so that people are convinced easily. That is actually not necessary. Coming back to the rules and regulations of India with respect to electrical safety, all of you know that we are governed by the Electrical Safety Act 2003. Electrical Safety Act 53 says the CEA shall make the regulations for the purpose of the Act, and in the Act 146, punishment, and in 49, offences by companies. All provisions are very well explained in the Act. So that means if somebody violates the electrical safety, there are provisions already available in the Act to punish the person. Who has to punish? Of course, it has to be initiated by the appropriate authority. So most of the time, for example, these punishments are not carried out properly. Say, for example, the regulation very clearly says the overhead lines should have guarding, so that in case a line cut and falling down, people are not getting affected, especially while road crossing, especially while railway track crossing. But you cannot find a guarding in our overhead lines. It's an offense. So very simple. The electrical inspector can straight away take a case against the electricity supply company, and they can be punished not for having this safety measure. But who does it is the question. Now, coming to the central CEA measures relating to safety and electric supply, of course, I am referring to the proposal 2022. I don't know whether it will be finalized or not, but the same proposals are there since 2016 or 2018. So, save otherwise provided these regulations, the relevant Indian standards and National Electrical Code or National Building Code shall be followed. So basically this part, what it says is whatever not contained in the regulation, you can refer to the Code of Practice of Bureau of Indian Standards to achieve safety. That means the regulation is mostly discussing about generation, transmission, distribution, and up to the point of commencement of supply, mostly up to the point of commencement of supply. Of course, there are regulations which is applicable for inside the house as well. So whatever the subject not covered in the regulation, you can refer to the Code of Practice. And for example, one of the regulation which is talking about within the consumer premises, regulation number 36 earlier. Now in the new proposal, it's regulation number 38. It talks about the owner or occupier of a multi-storied building shall ensure that electrical installation and works inside a building are carried out and maintained in such a manner as to prevent danger due to shock and fire hazards, and the installation carried out in accordance with IS 732 and National Electrical Code. Provided that hospital and medical establishments shall have safety measures as per National Electrical Code, irrespective of height. So probably, this is a new information. The new regulation says that you should carry out your design, erection, and installation as per IS 732, or compliance to IS 732 is becoming mandatory in some of the buildings, especially the high-rise buildings, more than 15 meters height. Also, the regulation, I think the number is 6, talks about chartered electrical safety engineer. Who is chartered electrical safety engineer? What is his qualification criteria and what kind of formats he has to follow. For example, what kind of test he has to do? He has to do test as per regulation 32, periodic inspection, and periodic inspection means every 5 years you have to do the testing which is prescribed as per this particular regulation. Then precaution against. I'm just showing you some of the regulation which is actually very much connected to the safety in an electrical installation. Say, for example, I have put the new number. I think the earlier numbers were 30 and 33. Now the new number is 32 and 35. 32 talks about periodic inspection and testing once in 5 years, for example. 35 talks about precaution against leakage before connection. This regulation says before you connect electricity to a consumer premise, you have to make an insulation resistance test, and the value shall be higher than 1 mega ohm. Unfortunately, these tests are nowadays not at all carried out, and this is one of the reasons for accidents. Also, the regulation explains the formats. The reason for showing these formats are probably in future, people will start doing the electrical safety audit as per this particular format. Please note that this format, which is Form 2 in the upcoming regulation, actually it is talking about the compliance to the regulation. For example, in a consumer premise, you see regulation 15, 16, 17, 18. This format is asking about the compliance to regulation. And in my view, if you fill up or if you do a compliance as per this particular format, of course, electrical safety on a large scale, it cannot be. In a residential case, it's okay, but in a large building, it will be very difficult to achieve electrical safety. In an industrial or in a large commercial installation, it is very difficult. So, however, these formats are already given in the standard in order to do verification by the chartered electrical safety engineer as per the particular regulation, and the chartered electrical safety engineer also shall carry these particular meters. Say, for example, one of the new incoming is a loop impedance meter. Fault loop impedance meter is also required. But again, for a larger industrial installation or in a medium level industrial installation, these basic testing equipments are actually not sufficient enough to make an electrical safety audit or electrical safety verification. Probably you can make an audit because audit is only partial. Verification is not possible. Why I show this, these tables are, there is one more regulation which I will refer a little bit later so that you will be able to understand the importance. So basically the problems are safety measures are rarely followed, especially, for example, regulation 30, 33, 40 are violated in almost all low voltage electrical installation. Guarding is not there. The protective regulation 14, 15, 16, the earthed conductor from the supplier side is not available in most of the state governments. So these are actually attributing to the large amount of accidents. Similarly, understanding about system earthing, TN, TT, IT. If you don't know what is TN, what is TT, and what is IT, actually you cannot do a verification. You cannot. Earthing is not about putting hundreds of earth pits. Earthing is about the best way of making one of these system earthing and ensure that all the safety measures are made. So most of the time, the auditors are very rarely aware of TN, TT, and IT systems. I am making this statement because of, with my experience, I participated in some of the electrical safety training organized by some international companies. Say, for example, you know, a lot of companies, those who make international companies, those who make trainings. I attended international as well as Indian after paying the fees, but most of them doesn't have any knowledge or any idea about system earthing. They always talk about earth pit and chemical earth. So knowledge on basic, the idea of basic protection and fault protection measures are very rarely understood. Each safety auditor have their own interpretation and assumptions. Most of the time, audits are made based on assumptions, not made based on what is written in the standard, which is actually not correct. Safety standards are unknown, verification is unknown and rarely carried out. As I said, please note that I am not using the word safety audit, I am using the word verification. Verification audits are made, but the result of the audit is a question. Verification is rarely carried out. Equipment requirements are often violated. Usage of wrong and exaggerated products. As I said, the exaggerated products are like this, something called as digital earthing, something called as chemical earthing. Nowadays, most of these chemical earthing companies become electrical safety auditors. So chemical earthing company becoming an electrical safety auditor, the result is he will try to recommend 25 numbers of more earth fit. The client buys it and installs it. This is actually not correct. So now I show you a small example of, rather than talking a big safety scenario, we should always start, or my way is to start from some small things. I'm just showing you the meter board from Bombay, which is used in most of the apartments. There is a room, a meter room, and all the meters and the protective devices are mounted on the wall. The first point to note is earlier it was a wooden board which was catching fire quite often, but nowadays the wooden board is stopped and cement boards, fire resistant cement boards are used. Anyway, congratulations, it's a good thing because the chance of fire on the wood is avoided, but still a lot of existing buildings have wooden board. But now, in this particular case, the funny point is the electricity supply company is using a 32 amps MCB, type C MCB at the meter board, and the owner of the builder, the apartment builder, has provided an additional MCB. Say, for example, near to the meter, there is a 32 amp single pole MCB, and these are at the top, these are double pole MCB provided by the builder, and these are 63 amps MCB. So the incoming is 32 and the outgoing is 63. Of course, the wire is not enough sized to carry this much current. So imagine a situation after a few years, due to some reason, if you bypass this 32 amps MCB, until the 32 amps MCB works, it's fine. But if you bypass under any condition, or if it is not working, then the chance of fire in this installation is quite normal. It can catch fire. So this is actually, it's a small thing. The builder can, instead of 32 amps, he could have given 32 amps. Instead of 63, he could have given 32 amps MCB. Unfortunately, the auditors or the electrical inspectorate engineers, or none of them take care of this particular thing. And after a few years, this room, which is at the beginning a neat and a clean room for electrical meters, becomes a dump yard. Most of the time, the key is with the security. Sometimes the security sleep inside. His dress is kept inside. In this particular picture, what you are seeing is a meter board, the electrical room, which belongs to the energy supply company in Bombay. So you can see here the wetness inside the room. The security fellow told he was keeping the diesel of the generator inside this room. So what do you need more than this in case of an accident? Of course, you see a lot of fan. That means all the bus bars are hot and they have kept fan to cool it down. So such situation shall not be allowed. The electricity supply company must be asked to improvise this. If we try to continue this kind of electrical installation, of course, even after 100 years, we cannot stop fire from electricity. So very pathetic situation. So we should actually not, going to the big level of safety. We should start from such small things. And this particular building, which I am showing in the picture, it contains a multinational bank at the first floor and second floor. And when I asked them, they already conducted an electrical safety audit. So basically, this building is an electrically audited building. And the basement looks like this. Now, please note that verification always consists of inspection and testing. there are two things. Inspection means physical inspection. It is not just like you run around the place and find out something. No, there is a sequence we are supposed to follow, and testing. Now, in the new regulation, regulation number 33, a big improvement has been made. Testing on consumers installation. You can see the first part. Let me skip it. Provided that recommended testing and verification as per IS 732 or National Electrical Code, wherever applicable, shall be carried out. So now the regulation also started insisting for verification as per IS 732. Now, if the National Electrical Code is saying some frequency of verification, the audit must be carried out as per IS 732 or National Electrical Code of India. Please note that I am referring to National Electrical Code of India, not the National Electrical Code of other countries like America, because if you search on the Google National Electrical Code, you will get information only from America, whereas I am talking about NEC of India. Now, the IS 732 and NEC, what do they say about verification? Verification consists of two subjects, inspection and testing. Inspection, there are about 18 points for inspection. The first one starts with the method of protection against electric shock. I made it bold because I will explain what the meaning of this particular measure. There are 18, but the first one, protection against electric shock. When it comes to testing, there are 10 testings included in the standard, whereas in my slide, I have put 11 testing. The 11th one is actually PAT, portable appliance test. Probably it may come into the standard on a later stage. So I will explain you the first one, resistance of conductors. So next two slides, I explain the first inspection point and the first testing point, so that you can ascertain the situation of your electrical safety in your building. Now, protection against electric shock. There are several techniques. Basically, you need to have a basic protection. You need to have a fault protection. Basic protective measures are there, such as live part, barriers, obstacles, placing out of reach, fault protection, automatic disconnection, ELV, separation, double insulation. There are different techniques. For example, in our last webinar regarding solar PV, we discussed a lot about double insulation. In a solar PV, especially on the DC side, protective devices for quick disconnection, automatic disconnection is not available. For example, fuses are not efficient enough to quickly disconnect. MCBs are not efficiently enough to quickly disconnect the supply in case of a fault. There is no ELCB or RCDs available. They are still under development. There is no arc flash detection device, AFDD, for pure DC application. So basically, disconnecting the supply during a fault is very difficult. There, for the DC side of solar PV installation, we are supposed to follow a system called as double insulation. From the terminals of the solar PV up to the terminal of the combiner box or up to the terminal of the inverter, the entire electrical installation DC must be double insulated. So basically, all these techniques are applicable for certain application. All these are, sometimes we may use one of the basic protective measure and one of the fault protective measure. Generally, the measure which we use for basic protection is insulation of live parts or barrier or enclosure inside a premise, inside a low voltage consumer premise, and for fault protection, automatic disconnection or extra low voltage. These two are made. Of course, separation is also made in some cases. So the auditor, first job of the auditor is to understand these safety measures, its application, and he has to find out the applicable safety measure for a given location. Location to location, it varies. If you have a computer, if you have an area with the computers, then sometime you may need to go for a separation. If you have a critical place with wet areas, probably you have to go for an extra low voltage situation. So the first job of the verifier, I'm not saying the auditor, verifier is to ascertain, or he has to understand the safety measures and he has to apply it appropriate to the location. There are measures sometimes for one measure which offers both basic and fault protective measure. So this is the meaning of the out of 18 inspection points, the first inspection point is protection from electric shock. The verifier must understand each of these measures, and he has to find out the applicable measure which is applied in a specific location. Now, once when it comes to automatic disconnection, which is one of the safety measure, especially used in AC application, MCBs are used for automatic disconnection. MCBs, there are three types of MCBs available: Type B, Type C, Type D MCB. I have put the tripping characteristics of the MCBs. Each of these MCB have got its typical way of disconnection, especially when it comes to instantaneous tripping. A Type B MCB 3 to 5 times the nominal current. Type C 5 to 10 times current. Type D 10 to 20 times current. So basically, these three type of MCBs must be selected appropriate for a certain location. For example, in a residential application, MCBs are to protect the wiring of the installation, not to protect your equipment, but to protect the wiring of the installation. Now, in a residential application, in the distribution, especially in the final circuits, we are supposed to use the Type B MCB. Type B MCB is more safer because it can even trip instantaneously at even a lesser current. This means even if the impedance of the circuit is a little bit higher, this MCB is efficient because each of these instantaneous tripping current is related to the impedance of the circuit. So MCB, Type B MCB is very much necessary for residential application. Of course, for industrial, it's a little bit different. But whatever the MCB type of MCB you use, you have to size the conductor accordingly and you have to have the impedance accordingly. Number 2, copper conductors used in conduit wiring. You know very well conduit wiring. I spoke about this subject several occasions, not now first time, several occasions. Copper in the wire generate heat. Once when we pull the copper wire through an enclosed space, such as a conduit or such as a trunking, the amount of heat which can be generated inside this confined space must be limited, not more than, say, for example, not more than 70 degrees. If the temperature is going more than 70 degrees, you end up with trouble. Now, the IS 732 has included filling factors, derating factors, voltage drop calculations, and several factors with which you can select the appropriate size of the wire. For example, the wire manufacturer may be claiming that 2.5 square mm wire can handle 20 amps, but practically in your building, you have to use it only for 10 amperes. You cannot use it for 20 amperes because you are pulling it through a conduit, multiple wires are there in the conduit, you have to derate it. These derating factors are very much given in the standard. So, electrical safety with respect to wire, there are two things. One is what happens before the fire. Next is what happens after the fire. After the fire, insulation is important. The insulation must have very, very limited smoke density, or in the other sense, the visibility must be much, much higher for a safe installation. Before the fire, conductor resistance is important, heat, because if the resistance of the wire is high, more heat is produced. In that particular case, wires are classified into class 1, 2, 5, 6. Class 2 and 5 are flexible wires. All the calculations in the standards are made based on copper conductor class 2. Now, I am showing class 2 and class 5. Class 2 is a copper wire with lesser resistance, 8% or 9% lesser resistance. Class 5 is a copper conductor with higher resistance. This means class 5 wire with higher resistance is more dangerous in comparison to class 2 wire. All the calculations are made based on class 2 wire. All the conduit wirings we are supposed to make with a class 2 wire. Unfortunately, both class 2 copper wire and a type B MCB are not available in the market. I repeat, for a safe installation, class 2 wire, I am talking about the smallest wire which is used in our house, class 2 copper wire, and type B MCB are not readily available in the market. So this is the actual fact of the installation. Now, I would like to stop the presentation with this. Thank you very much. We will go for a small question answer session. Hope the presentation was.
Yeah. Should we invite? We have invited 4 of our members here, sir. Would you like to take up the invite them to talk?
Yes, yes. So I made at the final slide, I made a presentation. I made a statement that the wire which we use, class 2 wire is not available. Type B MCBs are not available. Now, along with us, we have Mr. Riyaz Ahmad Qazi, who is one of the 5 chartered electrical safety engineer passed out from Maharashtra State Electrical Inspectorate. We would like to invite Mr. Qazi. Mr. Qazi, we would like to listen to you about your experience in the electrical safety situation.
Thanks, Gopal Kumar sir, and good morning, good afternoon. Thanks for giving opportunity. As far as electrical safety is concerned, I need to share that in industry, normally electrical safety audit is normally do as per the recommendation from the factory inspector or the electrical inspector of or the fire department for the sake of the for the doing. And normally the electrical safety audit what normally done is a walkthrough audit and general recommendation like rubber mat not available, earthing not checked. The general housekeeping related observation normally do, and as far as the requirement as per standard is not followed. And the main, I think the main issue is the awareness. As Gopal Kumar sir is already mentioned that the copper class 2 copper wire. I tried to search in Pune market. So class 2, there is no awareness about a good OEM or the good wire manufacturer. They're not able to differentiate between class 2 and class 3 wires. And similarly, I tried to find type B MCB, and I talked with a couple of well-known manufacturers. They are saying that normally type B MCBs are retail application. You can say some specific areas or specific residential normally installed. Type 2B, they're not able to give the justification or do the clarification technically what tripping time. And normally they say that if we install a particular type of MCB or RCCB, there is a tripping, and they're not able to address why they get tripping. Instead of they change the MCB type. That is not a good practice. So as far as audit is concerned, I think we need to address as per the industry. For a building or the government offices, we should have a different kind of audit procedure. And in the industries, again, the industrial, we have a different type of industry as per the risk. In my opinion, I am following NFA 70 from last 10 years. And in electrical safety, there are 2 type hazards we need to address. One is the electrical shock hazards, and there is a electrical fire hazards. So we need to have a proper checking mechanism or the audit mechanism to address. As Gopal Kumar ji rightly said, we should have a good checking mechanism during installation and commissioning, because once we do installation and put to in the circuit, then we're not able to disconnect on the sake of the testing or the verification. So whatever the verification we do during commissioning, that is a very good time. So after that, checking and verification will become difficult.
Thank you very much, Mr. Riaz. Thank you very much. We have Mr. Sanjay Mulai from one of the largest agricultural companies in India. Mr. Sanjay, you are following a lot of our webinars. We always see your name, but we never had an opportunity to speak. What is your experience in the subject question?
Yeah, thanks, Kumar, for giving this opportunity to speak on electrical safety. I'm working as a global principal engineer for whole Syngenta sites, and we have, presence in almost 200 countries. And I get opportunity to see all the regions, like from US till Philippines, APAC, and China, EME, Africa, everywhere. And one of the important thing which you spoke, I think, I keep a thing that electrical safety starts from the design stage itself. And when I'm interacting with the consultants, either in Africa or in US or in China or APAC region like Indonesia, Pakistan, Bangladesh, I'm finding that the concept of earthing, like what you said, TT, TNS, IT, still it is absent. Second thing is that people doesn't understand, between the exposed protective earthing and extraneous conductive earthing, still that concept is not understood very clearly. So what I'm finding that when I put in the design, they said you need to really thoroughly look into the IEC 60439 and talk about the grounding. Bonding is very important, and I'm giving more thrust. In fact, I used to start a word saying that if you don't take care of earthing, earth will take care of you. Like that statement, I start my training sessions and everything. So my experience is that the absence of IEC and the concept of earthing is very still not gone to the across all the regions as well, and people need to be educated on that. And after hearing your seminar from last 2 years, I have done my electrical, instead of I said like safety audit, I said yes, assessment or verifications. I know I made a lot many difference in my checklist, and wherein now like fault of impedance is one of the important which I inducted into that, and I'm started doing across the regions. And it really finding that it is being helpful for the other peoples. And apart from that the equipment like, AFDD or SPDs or the global earthing system, that also we started inducted into this our checklist. I'm discussing with every consultant in other regions as well. And I'm finding that I'm improving a lot. One of the another important thing which I found that, as you rightly said, the coordination between the wires and cables and equipment load and the MCB absolutely absent. Example, when I go for audit, I just check that, okay, you have one equipment like it is carrying 2 ampere current and its MCB of 32 amperes. Then I said, how it is going to trip? The whole thing will go into fire and the thing will, this won't trip, and over and above, there's no proper grounding, sizing also not there, absent. So there's a lot of gap, not in India. I can share you because I worked with other regions and I say that it is a tremendous gap in understanding the load coordination. I refer IEC 6036-49 or IEC 620-305 because the concept of ESC and CAC was going earlier. Then I stopped using the CAC and ESC. I said, you do the proper risk assessment, whether we found out the risk calculation, whether is it necessary to do the lightning protection, what size of lightning protection, everything has to be done as per IEC 62305. So many things, Gopakumar, we learned from your sessions and did many improvements on our checklist. And it is really getting useful because I'm finding that the consultants are listening now. They started saying,
Thank you.
Which is happening now. I think that's what I want to, because we have limited time, so I could able to share something experience which I had with in my industry. Thank you very much.
Thank you very much, sir. Thank you very much, sir. Thank you. Thanks for your comments. We have one more gentleman whom we invited to have share his knowledge, Mr. Jerome Lobo. He was in the industry for more than 30 years, retired recently. Mr. Lobo, we would like to listen to you.
Hi, good morning, Mr. Dominic and Mr. Gopakumar. Thank you for giving me this opportunity. Like Mr. Kazi said, I too went, and checked for this type B MCB and also for the class 2 wires. In fact, some of the reputed shops in Goa, I checked in 2 cities, and both of them, first they were not aware of class 2 wires. And then when I said I said it'll be written on the coil. So they went up to the coil and they said, no, this is class 5. So I said, I want class 2. So when I asked them for class 2, they were a little puzzled. Then they said, no, we'll get you. You give me the order and we'll get it for you. So I said, why can't you give it to me now? He said, no, sometimes we don't have the colors. We don't have, stock availability. So I'll get it. But he didn't want to say that he didn't have it. Similarly, I went for MCBs, type B MCBs. I checked with 2 reputed brand, which sell reputed brands, and both of them had only type C MCBs. They said, if you want, I can get it to you within a week, but this is normally project requirement. It's not this thing, but if you want, I can give it to you. And coming to, the audits, like you said very correctly, the audits are more of a sampling, whereas you have to do a verification. In fact, when we used to do audits, it was more like you said, some sampling thing, and we would check like things like earth pits, we check lightning arrested tests, we would check oil filtration, check ACB servicing, we would check thermography, load testing, interlocking, previous audit points, whether they were cleared, load balancing, health of insulation, HERA, double earthing, LOTO, training of people, calibration of tools, single line diagrams, permit works, so these were all the things that we would check, which maybe are necessary and are good. But the basic, like you said, the resistance of the cable which has been put there, have we verified it or are we checking it? And will that actually prevent the fire or prevent the MCB or the protective device from tripping? I think that's one thing that we miss in all these audits. And like you said, it's more, we have to do a verification than an audit. Thank you.
Thank you. Thank you very much, Mr. Jerome. So we have Apau sir. You can you share your experience, or you are on mute?
Thank you. Good morning, Gopal and Mr. Dominic. Very interesting session. So you have covered important areas. I would like to limit to 2-3. Previous experts has already explained in detail about the protection measures and audit measures. What I would like to say a few things in this forum is, first of all, inspection for verification. That's a major job, because audit, as you said, audit is not specifically stipulated in any of the codes or standards. But still, I hope that NAB, that's National Accreditation Board for Hospitals, they require audit, and most of the consumer installations from MNCs, they require audit. So my opinion is we can use that for sensitizing the consumers to verify all these things, because verification, as you said, is very tough process for each and every thing in a running installation. So what the audit can aim is, it should be a consumer and the auditor interactive, what do you say, the norms should be fixed between the auditor and the consumer. So for this, a standard should be evolved. What should be the audit norms? A practically viable audit norms. In my opinion, the initial design itself is not coordinated. Whether they take into account of fault level, a power system analysis, or a power quality issues that crept in the later stage, which can infest the installation with power quality issues like low frequency and high frequency noise setting, which ultimately affect the performance of sensitive components. Like, for example, an echo machine, it can malfunction because of these issues. So the audit can concentrate at the initial observance, whether the consumer has observed all the design aspects initially, whether they have done verifications initially. The audit team can check measure few samples, because it will become a Herculean task to check each and every aspect. So they can be the audit team can be an empowering knowledge sharing person to the engineers in the premises, in the facilities. Number one. Another thing, of course, earth resistance and the thermography are also not mentioned in the specifically mentioned in the standards, but it occurs in certain locations. For example, a bus bar heating can be transmitted to the wire insulation. But what people use, the thermographic instruments are not reliable. It depends on various factors, conductivity, emissivity, everything. And as a result, the resultant is a failure. It will be creating a very concern to the consumer. They will be fearing, oh, my bus bars are heated up to 120 degrees, but the cable can stand up to 80 degrees. What is the point at the cable, whether your measurement is correct? So ultimately, the purpose of verification is by wrongly interpreting these things. Another thing, type 2 coordination. It is totally missing in all the instances. People are having a concern over the type 2 coordination, availability of conductors as well as especially beacon MCBs. For example, in every domestic premises, for example, if I have a 1.5 kilowatt geyser and I have to select based on the design current of 7 amps, I have to select 10 amps MCB, but I have to use 4 square mm cable. Then only to be compliant. If I use a C curve, it is not possible. You have to provide a 6 square mm cable, which is very tough. So people do not observe 100% of installation. I can certify that type 2 coordination is missing, except very few places. In domestic premises, totally missing. The absence of B curve MCBs is also adding to the fire to the fuel, and it is driven by the marketing mechanism. The manufacturers will always tend to produce more on what is the availability, what is the requirement. So it is a feedback and a driven mechanism. The electricians and the consumers are not aware. They have to play a major role, and the enforcing mechanism should also have to play a major role in fixing these issues. So these are all my opinion, and I would like to
thank you very much, sir. Thank you very much, sir. Thank you very much, sir. So hopefully, Mr. Dominic, I have answered some of the questions online.
Yeah.
We have
so we have a lot of questions coming in. I think let's take these questions are probably relevant to today's subject, and also for audience it will be interesting. So I'll take it quickly and we'll run through this quickly and complete it as much as possible. So let's start with Balaji. He's asking, safety officer or safety manager can conduct electrical safety audit? That is one question. We have a similar question. Where can I get certification to do an audit? These two questions you can answer.
Yeah. You see, at the moment, legally, other than chartered electrical safety engineer as per section 5A of the regulation, there is no other legal requirement. Now, this regulation, it is the state government who is supposed to implement it. Only few states went ahead with appointing chartered electrical safety engineer. One is Maharashtra, where we have 5 people already passed, but there is a clause in the regulation, or there is a clause in there is a condition. Say the chartered electrical safety engineer shall work only as chartered safety engineer. He shall not work in any company. As a result, out of 5 who passed, only 1 person hold the certificate. So 4 cannot do the job. So these are, flaws in our little bit flaws in our system. But the question is, the there is no agency who decides the criteria of energy, chartered electrical safety manager or electrical safety engineer or something like that. So as per regulation, only while contracting or while installation, some qualification criteria are made, and for chartered electrical safety engineer, some qualification criteria are made. Other than that, there is nothing present at the moment.
Probably so I request, go ahead, sir. Go ahead.
Yeah, probably in future something may come. Thanks for the question.
Okay, I request members of putting up questions. Please mention your name. I generally do not take questions, but this is I felt the one question I will take from anonymous attendee. Does the verifier inspector require any basic eligibility to audit, or electrical department is conducting any training? The same repeat question, but anyway, eligibility is something that the verifier inspector require any.
Actually, at the moment, this do not exist. The purpose of making this association, the National Federation of Engineers for Electrical Safety, we will be able to make an accreditation system. Yes, it can be approved by the government, because there are some rules and regulations and the standards available with which these jobs can be made by an accredited engineer. Worldwide, this is how it works. The government don't control such activity, because then government needs so much infrastructure. So this is made by the accreditation system. So our association NFE will be we will try to create the accreditation system based on the Indian rules, or probably from some international accreditation agencies. We started the work, and probably in a few months or sometime 1 or 2 years, we will be able to set up this facility. And after that, then we can talk who is the electrical safety manager, who is the electrical safety engineer, who is supervisor, something like that. But there shall be a system first in place.
Thank you. Sanjeev Deshpande is asking, what are your views and say on harmonic audit?
That is a subject which is related to power quality. With respect to safety, you can refer to IS 732. Safety and power quality is very much written in the standard. The only requirement is, in case of, if the current through a conductor is more than certain limit, you are supposed to disconnect the supply. That means if the power quality is so low, you are not supposed to use the electricity. First, you should make it clean, and then only you can use it. Now, power quality, there are two issues which we face daily. First of all, every equipment is supposed to create or the amount of harmonics which is created from the equipment must be limited to certain level. This means, say for example, 3% or 5% total voltage harmonics. But in practical, our equipment are generating much more than what is recommended or what is written and included in the standard. So the first culprit is the equipment. Now in Europe and other countries, if you have a larger equipment, let's say for example a variable frequency drive, because of its inherent working principle, the drive is creating a harmonic of more than certain limit. The manufacturer is supposed to put a filter at the beginning, and he is supposed to filter out the unwanted harmonics, so that only limited harmonics are allowed in the line. Whereas when it comes to India, the same VFD, variable frequency drive, the supplier will tell you, sir, I have got a filter and I have got an inverter, I have got a VFD. Then cost is without the filter is 1 lakh rupees, and with the filter is 1,50,000 rupees. So we always remove the filter and we use it without the filter. As a result, we end up with more harmonics and troubles in the line. With respect to safety, the only written rule is, for example, in neutral, if the neutral current is more than certain limit, you can increase the size of the neutral conductor to certain limit. Still, if the current is more, you are supposed to measure the neutral current and disconnect the phase conductors. Very simple. So measure and disconnect. This means you are not supposed to run a dirty electrical system. Dirty in the sense with a lot of harmonics, more than certain limit.
Okay, moving to next question. Morgan Mulenga is asking, how do I identify class 2 copper wire? Copper
Wire.
Wire.
Actually, some of the, at the moment, it's very difficult. Once when this becomes popular, of course, the manufacturer will put it on the label or they may print it on the cable. First, there should be a demand. People should start asking for class 2 wire. And once when there is a demand, then the market decides. Automatically, the manufacturer will put all these seals. At the moment, nobody asks, so there is only one type of wire available in the wire, which is class 5. So you don't need to print, you don't need to really tell that it is a class 5.
Pradeep Shah is asking, would like to know the impact on safety due to aging factors in MCB and wires. What is the age normally you recommend for wires and MCBs?
In a properly designed and installed electrical installation, it is minimum 20 years. But this means the minimum is not, this is the average. The minimum is 20. It can be an average of about 30 years. And if you are maintaining it with correct periodic verifications, then it can go even up to 40 years. For example, in Europe, let's say in Belgium, for residential purposes, the frequency of periodic verification is about 25 years. So initially you do, once when you start your house, the electricity in your house, you do the verification. Then the next verification is after 25 years. That means the life of the installation is at least double of that. So I would say the answer is, let's say 40 years in a properly designed, installed and verified installation. If these three things are not carried out, probably 5 years.
Sachin Patel is asking, as a verification is quite difficult during audit or inspection when system is working mainly in hospital and commercial buildings, how and who can do such inspection to get actual result for further improvement?
Yeah. Mr. Sachin, actually the concept is once when we start, initial verification is 100% mandatory, and all the defects which we see in the initial verification must be rectified. Then only we are supposed to run the electrical installation. However, this concept is quite new in India. It do not exist until now. Now, imagine you have a hospital which is already running. Of course, verification is possible. Not 100%, probably 90% it's possible. The measurement, say for example, if you wanted to look at the resistance of a conductor, of course you have to switch off the line and we have to measure practically the resistance of the conductor. But the advantage of this periodic inspection is we have the habit of using electrical appliances, which is sometimes very difficult to understand. One such device is the stabilizer, the voltage stabilizer. Voltage stabilizer adds impedance into the line. Impedance into the line means that automatically the fault current is less. This means the disconnection, you are losing the safety. For example, you have an air conditioner. You have the MCB DB from which you take the wire. Let's say you have a 20 amps MCB. Then you take the wire and you at the socket you have a stabilizer, a 4 kVA, 5 kVA stabilizer, and then you connect the power supply to the air conditioner. Most of the time, air conditioner fires are due to either a line to neutral short circuit. Actually, internally there is a fuse which is supposed to disconnect that particular short circuit, but the current is not sufficient enough to disconnect that fuse because the stabilizer is adding a series impedance into the line. As a result, the current is lesser. Over voltage or over current, it will work, but not for instantaneous current. Similar is the situation with earth fault. Instantaneous tripping of the MCB may not happen. So such challenges also we need to handle. So periodic verification is very much necessary. You cannot avoid that since my installation is complicated, I don't need to make a verification. That is wrong. Periodic verification will be able to find out the new challenges, which is probably not faced during the initial days of electrical installations. Of course, periodic verification can be done, we are already doing. In fact, we are making verification, or sometimes they send the somebody is making, some auditor is making, the hospital is giving us the inputs, and we are guiding them what to test, how to test, when to test, then checking the single line diagrams and guiding the hospital's owners or the engineers in the hospital as well as the auditor to make it perfect or more better. Thank you.
Thank you, JK. Utsav Dave, what type of earthing to be done while construction of wharf jetty piling? I
think we should avoid the questions with respect to our. We should concentrate on. We should concentrate on the subject, Mr. Dominic.
Related today, yeah. That we have very specifically said we'll take up only questions related to this. But anyway, Ravi Gavde, I understand your questions. Yes, we are likely to launch. I'm taking the liberty to say we're likely to launch in Mumbai, the Federation of Engineers. I'm sure we will definitely consider you being there once the website is up and membership is up. So we'll seek your support. Thank you for that, to coming forward and also translating in Marathi for the benefit of the engineer. So should we take this anonymous? No. I was hoping to talk about short circulating also. So Jay Gupta, my request to summarize and mention all national, international electrical safety codes, standards, rules for hospitals and medical day care installation in terms of fire and life safety, patient and staff. Oh.
Yeah, Sir Dominic, this is a very good, in fact, very good. For example, in and medical location, first, if we start from the equipment onwards, there are different type of equipment which is sometimes connected to the body of the patient. So these equipment must satisfy the standards, the ISO standard. Each of these equipment, be it very small or the larger one like ventilator, each of these equipment should satisfy its own safety standard. Based out of, probably it is made by either by ISO or by IEC. Once when you plug these equipment into your electrical installation, of course, the other safety installation standards are applicable. If we tell the number, for example, equipment, for example, ventilator alone, I think there are 6 or 7 type of ventilators, high frequency ventilator, some emergency ventilator, I don't remember it exactly. You can find this information in the ISO website, International Standards Organization, ISO, in the website. Thank you.
Thank you, sir. Ravi Gowda again is highlighting something which is very important for all of us to know. He's saying in many rural areas where LPG bottling plants, pumping pipeline stations are managed by civil or mechanical engineer for HPCL, BPCL, which are government companies, and they do not have dedicated electrical engineer, or even the contractors do not have license also. What government inspectorate doing for such situation? These are hazardous industry in remote areas. So he's suggesting, I think Mr. Pau or somebody who was the electrical inspector, how do you ensure that qualified people maintain this system?
Actually, I would like to add another point here. More than somebody going and inspecting, whether the systems they follow, are they in line with the advanced things? For example, the LPG bottling plants or this the pipeline, cross-country pipeline, every, I think, 50, 60 kilometers, there is some control center. These installations are made based on OISD, Oil Industry Safety Directorate guidelines. This guideline, Oil Industry Safety Directorate, it's a government organization where the members of this organization are deputed from BPCL, HPCL, all the petroleum companies. I happened to read some of these standards, and initially I was laughing for half an hour. They were asking for 7 ohm earth pit for something, 2 ohm earth pit for neutral, 1 ohm earth pit for electronics, and there was a a station somewhere in Visakhapatnam. They were trying to bore a well of almost 200 feet to make an earth pit. So, first of all, the systems followed itself is not according to the standard. Of course, their documents, they always claim that it is as per IS 3043. Unfortunately, it is not at all as per IS 3043. I have written 3-4 times to them, but the problem is that the engineers keep on changing. They come on deputation for some time and they change. As a result, until now, no changes happen. If the installation is made perfect, then the question of inspection comes into picture. I would like to have the answer from Apau sir. Apau sir.
Yes, sir. Actually, inspection for installations are based on the state government notification. If it comes under the central government, the Central Authority Inspectorial Wing will inspect. I hope these installations are coming under central government and CE authority. But they have fixed the voltage classification as above 11 kV. In our country, the voltage classification for inspection by inspectors are fixed at various levels. Above 650, above 11 kV, above 33. So it's not uniform. So we can't say that an electrical inspector can go and inspect all these things unless he is empowered by the state government according to, actually the government issue notification based on the strength of inspectorial organizations. For example, in a state with 60 inspectors, there will be 25,000, 30,000 installation of 11 kV only. They can't go on inspect periodically these LT installations, which can be in the order of less than 11 kV. For the central government also, it will still become a huge job. That's why the CEA has provided regulation to notify the CESCs. Unless the CESCs comes into picture, unless the CESC scope is implemented, these problems will never persist. This is my opinion, sir.
Thank you, sir. Thank you, Mr. Apau. Mahesh Kumar, who can make the safety audit? Is there any certification? It's already clarified. There is no such. But however, the association, a non-profit organization called NFE, which is going to be launched, will introduce accreditation certificate in the near future. Maybe there could be some kind of certification program that we can run through that. So we'll come back to you on that. So Pradeep Shah, nowadays wires are available in FR, FRLS, HR, FR, low smoke halogen in the market. Would like to know if there are any usefulness technically. All this, is it useful technically in view of safety precaution?
Actually, I am not very much a supporter of these words, in fact. Because when we talk about anything related to wire to an engineer working with a wire company, they always confuse us with these technical words, FR, FRLS, FRHS, and after a few minutes, we are totally confused. Basically, FR is a wire which during fire, the property of that plastic is during fire, it emits the smoke. The smoke density is, I think, about 80%. Probably not 80, maybe 70%. I don't remember exactly. FRLS has got a smoke density 10% lesser. Actually, in the standards, instead of calling the smoke density, we should call visibility, which is actually the opposite of smoke density. If the smoke density is 80%, visibility is only 20%. If the smoke density is 70%, visibility is 30%. Now, any high-rise building or any building, I am talking about what is written in the IS 732, any critical building, in the escape route or in places where the evacuation is happening, a minimum visibility of 60% is mandatory. In order to get a 60% visibility, the wire should be zero halogen. That means halogen-free wire. Halogen-free wire has got a 30% smoke density, means visibility is 70%. So, I would say now in the market there is halogen, zero halogen cable, then somebody calls as less halogen cable, somebody calls as FRLS. These are actually quite confusing. Of course, the FRLS can be used for the normal areas, and in all the services related to fire safety, you should use zero halogen-free wire. Thank you.
Yes, as per NFPF, not NFPA, NBC Part 4, the cable from the power to the control panel need to be FRLS, so that to avoid the wire need not burn. So there are certain codes for the fire regarding. Rajesh Trivedi is asking, during the electrical safety verification audit, what is the right technique to check section load versus current load? Self-life of electrical installation and risk of fire. Rajesh Trivedi, sir.
One moment. I could not see the question because I was during electrical safety verification audit, what is the right technique to check the section load versus current load? Self-life of electrical and risk of fire. Actually, the standard point of view, the shelf life and section load, these are not very much mandatory. When we talk about safety, you have a protective device, you have a wire to carry the current to the load, then you have a load. You should find out whether the protective device is able to disconnect the supply before the wire catches fire, or before the wire creates a kind of shock or a safety hazard, and this entire system is working properly. Now, with respect to load and current, okay, of course, these are load analysis. This has nothing to do with, not directly related to the verification of safety. If you wanted to check your load analysis, let's say you have a connected load of in a typical shape. If you wanted to find out how the load is, how the electricity is consumed in your installation, morning how much, evening how much, due to, during your production process, how much you are consuming, those things you have to make a load analysis.
Thank you. Rajesh, okay. Pramod Dwivedi is asking, kindly confirm temperature measurement on both places like terminal points and body power contractor. Some person saying only temperature measurement at terminal point is okay.
No, the first point of measurement is the continuity resistance. If there is a loose contact, of course, high temperature can be created once when the conductor carries current. So the first test which has to be carried out is the continuity resistance test. Once when you do the continuity resistance test, which is an initial part of the initial verification, you know the number of loose contacts, and if loose contacts are more, or if there is a loose contact, you will immediately come to know. Now, in an installation where this measurement is made, probably after 5 years, if you make a thermography or a thermal analysis, there are almost nil hotspots. First, you should make this 10 testings, or first you should make the verification proper. Then you should start checking whether it is creating, probably, checking with a thermometer, a digital thermometer, it can be a part of a routine check, but it is not included in the verification process. Thank you.
Nikhil Jain is asking, can we recommend lightning arrestor in a storage shed where cotton fiber is stored and no electrical fittings are there?
Actually, this is not related to our subject, but anyway, of course, if there are cotton or some material, for example, in the northern part of Chennai, 2 years back, there was a lightning, and the entire shed where the tobacco was stored, it caught fire. There was no electrical installation. It caught fire. Of course, if you don't have a lightning protection and an equipotential bonding, lightning will create a spark over inside the building, which can catch or which can ignite a fire on the other materials, which is a disaster.
I think Ullas Vajra is just clarifying, during electrical safety audit or verification, thermography plays an important role, because what you can't see in naked eyes can be seen in thermal image. 100% verification is impossible because 99.99% client won't allow you to shut down the whole to measure the loop impedance. Is it correct or wrong, sir? Are you agree?
No, loop impedance test is an online test. You don't need to disconnect anything. You don't need to disconnect any of your equipment. It's an online test. So if you cannot make an offline, of course, insulation resistance you need to switch off. Otherwise, some of the tests, I don't know whether you have noticed, I have put as green and red. Green are in off condition and red are in on condition. Most of the tests which has to be carried out periodically is included. These are online tests. You don't need to really switch off. Number two, whether the thermography, of course, as a mandatory verification, thermography is not yet included in the IEC standard so far as for the low voltage application. But as an additional, you make the first verification very clear as per the standard, then over and above you do whatever you want. As an additional method, you can do it. But by making only thermography, don't expect electrical safety in your installation until and unless these 10 tests and 18 inspection points are not made.
So Nikhil J, this is something even I wanted to know. I know it is relevant. I wanted to understand why we should recommend metal conduit over plastic ones for wiring.
Yeah, it is mainly in exposed places for mechanical reasons. Also, in case of plastic, the fire, the chance of smoke is much more, which is actually killing people. But inside the concrete or inside the sealed places, of course, plastic is possible. Exposed places, it should be metal. But I think most of the time we use the plastic even in the exposed place.
Yeah. So Davis Alapadan, how can we audit thousands of electrical installations, buildings? With limited electrical inspector and chartered engineer, verification is almost impossible. Do you agree?
I agree to this. We need thousands of electrical verifiers, or not inspector. I don't call us inspector because inspection and testing. We need probably not thousands, probably lakhs of verifiers for doing it. So there is a good employment opportunity. Our association will become a platform for creating these verifiers by training, by accreditation, and by various methods. Thank you.
Sir, Jay Gupta, the question is big, but seems to be very relevant. Shall electrical safety inspectorate, AHJ of the respective state, make it mandatory, compulsory for hospital facility before granting occupancy certificate, license or renewal to such critical infrastructure to use most appropriate and standard electrical cables, wire and appliances? So, fire and life safety, and make a declaration every month to concerned authority that no deviation has been done in the installation.
Yeah, sir, actually, I have actually a different idea on it. The electrical safety, especially all safety matters, it should be a personal responsibility. It is not a responsibility imposed by somebody. If we think that I will do it only if the government says or if the inspector says, actually the system don't work. Not only this is the method which is followed all over the world, especially for mass protection, houses, hospitals, small scale industries, low voltage basically installation. The idea of making the notified voltage and above the notified voltage by the inspectorate and below is by the chartered inspector or whatever is, it is a part of ease of business or easy of doing the things. And if you think that we have to do everything according to the inspectorate or inspectors guidance, actually it won't work. Standards are made for that particular purpose. Regulation very clearly says anything not contained in regulation, you should follow the code of practice. You should understand the code of practice and you should follow it. That's how it works.
So Amit Shinde is asking, may I know exact procedure for electrical safety audit from the construction stage to after construction. Also, if fire incident happened due to electrical short circuit, then there is any rule, regulations, or law to do electrical audit.
From the construction stage onward, sorry to say that it's not audit, it's verification. From the construction stage onward, there are, if you look at rules and regulation, no, there is not much, but there are standards available. Code of practices made by Bureau of Indian Standards. They are already available. You can refer to the code of practices and you can follow what is you can follow the recommendations of those code of practices.
Okay, we have a few more questions, maybe 5. We'll run through this fast. Good afternoon, sir. I want to participate.
Dominic, also somebody had raised the hand. Probably, if
raise
anyone.
The hand. So I thought, let me complete, then pick up them. Those who raise the hand, we'll allow you to speak. Just give me another 2-3 minutes. So we have another 5 more questions. We'll complete it and take it. So you keep your hand raised. Lakshmi will allow you to come onto the screen, and it's only a voice, so you can overtake. Sir, Amit is asking, this is a very informative. I want to purchase IS 732. Where can I get a copy?
Oh, it's very easy. It's free. You can go to the BIS sales portal, create an username, password, and download it free.
Amit, hope you got the answer.
Yeah, Google BIS sales portal so that you get the correct link.
Okay. After your answer to the one about stabilizer, Smruti Ranjan is asking, can we remove stabilizer from AC?
Actually, nowadays, most of these equipment, nowadays voltage fluctuations, especially in cities, voltage fluctuations are that bad in comparison to the olden days. Number 2, most of the air conditioners, the inverter air conditioners, which is coming in the market, they claim that the stabilizer is not required. So it is better to remove it if we think about safety.
Okay. Would you like to take Pramod Dwivedi's question? It's quite a long question.
Oh, in the premise, short circuits are happening frequently due to loose connections with fixed electrical socket, which are mounted in wall with multi-plug extension board. In panel, RCCB 30 milliampere is installed, but it takes more time to operate by socket. You should understand that the RCCB of 30 milliampere, that will protect only against earth leakage or earth fault. Most of the time, the items which we plug into the extension board, they are class 2 equipment. Say, for example, mobile charger or sometime laptop chargers and all, they are class 2. The RCCB is of no use in that particular case. AFDD can protect, of course, in the new National Electrical Code, especially bedrooms. AFDD is recommended. The third part is if you have so much equipment, of course, number 1, we are not supposed to use this multi-plugs or putting so many plugs into one socket. It can create sparking and problems, but AFDD is a solution for that. But if you have an AFDD and if you still continue to plug in, AFDD will trip. As a result, you may not be able to use your electricity. You should also keep this in mind. Thank you.
Okay, thank you. We have 7 minutes to go. Chatur Vedula Narsimha Murthy, if you have any questions, please unmute and you can talk.
Okay.
I think, Chaturada, your audio is an issue, so you can come back after there is some echo in your this thing. So, Beherella, could you unmute and come? Can you talk, please?
No, sir. It's a good section. All doubts are clear.
Yeah. Nice to hear that other questions has clarified your doubt. Okay, thank you very much. Okay, Pranav, you have anything to ask the speaker?
No, he has changed his raise hand. Now Mr. Kalyan Srinivas, who has raised.
Morgan also there. You would like to talk?
Hello, sir.
Yeah.
Hello, sir.
Hello. Can you get me?
No, tell me Morgan. Let Morgan talk, then Kalyan will talk.
Hello,
Okay,
sir.
okay.
Good afternoon, sir.
Yeah.
Let me mute.
Myself, Kalyan. Hello.
Yeah. Go ahead. I can hear you.
Sir, and actually, capacitor banks harmonic contactors is connected in my electrical department. In this panel, 415 volts contactors reduce ITHD. That purpose are connected to this type of harmonic filters are connected. But sometimes the contactors are suddenly burned, but not protect that type of contactor fired and any short circuit. But please give me your suggestion, sir.
So Srinivas, I am unable to get the question. I think you were asking, you have contactors, the mechanical contactors in your automatic power factor correction or in some of the panels, and these contactors are burning. That is the question. Of course, if you capacitor switching and the contactor burning is quite common because the inrush current of the capacitor is quite high. As a result, the contactor joints get either welded or it gets damaged. I really don't know how this problem is solved. I have seen some of the companies, those who are having special capacitor duty contactor. You should use those kind of special contactors, not the normal one which is used for motor duty.
Or other option, you use a thyristerized controller.
Yes, thank you, Mr. Riaz. Yes, thyristerized, the semiconductor-based switching device, which will switch on the capacitor during the zero crossover. So, I think Mr. Pranav, I think there is no.
Pranav not answering. Ashok Rane, is anything? Would you like to talk?
Hello.
Venkateshan Egambaram. Okay,
Ashok Rane.
Yeah, I wanted to know when the membership will be open for NFF and how we'll get the communication, either email or some of the webinar.
All of you will get the communication. All those who are in our mailing list will get the communication. We are working very hard to make it. But unfortunately, due to our various travel and other schedules, it is getting delayed. Definitely, you will get information. Mr. Dominic,
Thank you.
Yeah, Ashok, we'll get back to you because we have your mail ID. We have almost 8,000 to 9,000 people who've been attending. So everybody will get an official mail, an invitation mail to visit the website and enroll as a member. And also we'll be launching this in the month of February. So updates will be given as we progress, as we develop. You will be getting the intimations about it. Anybody else? Okay, Venkat.
Thank you.
Thank you. Tell me, sir.
Thank you.
So, I think it's time to.
Venkatesh.
Yes, sir. Good afternoon, sir.
Yeah.
Sir, we have recently installed on-grid solar system in our IRS buildings. That is connected parallelly to our class 4 system. We have one doubt for suppose we are doing maintenance in class 4 system for regular maintenance time. Any further isolation is required in on-grid connections, power supply connections for safety?
So that means while making the maintenance in your regular electrical installation, do you need to shut down the inverter of the
on-grid systems? Yes, sir. Exactly.
Of course, these will be a part of your panel board, and this will be a part of your process.
Yes, sir.
Is required.
Part of the process, sir. What I'm suppose anything feedback return back feed from solar to class 4 is possible, sir.
Actually, what do you mean by class 4?
Class 4 means our power supply, EB power supply.
Okay, it depends on whether your electrical installation is your solar PV inverter is electrically isolated or electrically separated or not. There are two type of inverters available. One is electrically separated inverter and the one is without electrical separation. Actually, we discussed this in our last program in detail. If you go to the website and look at the video, you will be able to understand.
That time.
You can look at the video.
Okay,
Okay.
last question. I'll ask Avinash if you are there. You can take up this question. Avinash. Okay, we'll close.
Hello.
Avinash. Okay, Avinash, go ahead. Last question.
Yes, sir. I'm Avinash Mohite from Sangli, Maharashtra, and I'm a fresher electrical contractor in this field. And my question is, how can I enter the electrical audit or electrical verifier field? And how can where can I learn all the details and professional electrical auditing field?
Sir, as I said, we are launching this non-profit organization called NFE. So we will be doing a lot of courses, accreditations, and all that, and become a member and keep watching out various trainings, workshops, and this thing. So over the period, you will able to get certain knowledge and certifications and all that. That's what I can at the moment. I can tell you, we are now just a minute away. I would like to request all the participants still who has doubts, still who are unable to speak. We have given Mr. Gopakumar's mail IDs and mobile number. I would prefer you to mail because phone is not appropriate because he is already flooded with continuous phone calls. Please write to him. His office and his assistant also can help you in answering your questions. Second, Cape Electric, has been doing a lot of free knowledges, and Gopakumar as a person has been sharing his experience and openly saying what is right, what is wrong. They also do audit. They are a professional body, and they also have divisions to do fire safety audit. Those who are interested to audit, please write to them directly, and they will be able to guide. And those who would like to get involved with SOL, which you can see in its background, which is safe operation, low voltage electricity, you can get more details on that also too. So last closing remarks to Mr. Gopakumar.
Actually, Mr. Dominic, we don't do audit. We do verification.
Oh, I'm sorry. You told me. The word audit is not the right. So
actually, in a lot of places, how the relation starts is customer after attending some of the webinars or through some channels, they get in touch with us and they say, last year we did an audit. This is the report. How we can improve it. Then the discussion starts, and probably the audit is done by the same person itself. Only thing is, under our guidance, they do it. So we are actually working like a channel in between the customer and the auditor. Of course, we also do, in some critical cases, we also do the audit. So thank you very much.
Thank you. So we have already given you a link for the part 2 webinar, which will be held next Saturday at same time, 11 o'clock. You can please invite your friends and colleagues. Today we have 830 participants. Out of that, almost 400 people attended, which is around 50%. Exceptionally good based on our experience. And I'm sure the next session, next Saturday, part 2, will have many more participants. And your participation, comments is inspiring us. These are the things that motivate us to do more and more. We welcome your testimonials, what you feel about this webinar, how it helps you. Maybe in some cases, you're able to take this knowledge and implement, and the customer is happy. continue to write your comments, write your testimonial. We would like to put that in our website and say such a person gained knowledge out of these various webinars that we've been doing. So thank you, Apav, and all the gentlemen who also came on board. Thank you very much. God bless you. Have a wonderful, safe weekend. And we look forward to see you again on next Saturday. Till then, stay safe. Thank you. Bye-bye.
Thank you very much. Bye-bye.